Hello. So we are going to learn about parallel lines and transversals. So there's some prior knowledge that we have with this, and the first thing that we're going to go over and talk about is just some vocabulary. So first of all, parallel lines. So parallel lines are two lines that never intersect, and so finish writing this. So when we're looking at parallel lines in this diagram up here, the parallel lines I will highlight purple. So these are the parallel lines. Now, typically what will happen is if, in a geometry diagram, if they want to indicate that the lines are parallel without saying, hey, yo, those are parallel, what they're going to do is they're going to use some notation, which would be like a little arrow there to show, and there'll be matching arrows. So to show that these are parallel. And so that little arrow, it could be like that, or it could just look like this. And that would indicate that they're parallel. Okay, so these are the parallel lines. So what that means, they never intersect. They're the same distance all the way through, all the time. Okay, so the next thing that happens, so along comes we have this parallel lines, and another line decides to go through it. Okay, and so that line is called a transversal, and that is the pink line here. And it is a line, so it is going to cut across this. And so as it does that, what you're going to see here is you're going to see that it has two places where it crosses. And at those places, it's kind of interesting, angles are formed because we end up with a vertex of four distinct angles. And if we really wanted to get technical, it's more than four. But we're not going to do that. So we've got 1, 2, 3, 4 angles here, and 1, 2, 3, 4 angles here. And so that's the result of having two parallel lines cut by a transversal. Now, we already know some relationships about those angles at those individual vertices. Okay, and so we're going to come over here and we're going to talk here about what we learned yesterday about these angles. So there's some specific angles here that we know. And if you're remembering this from yesterday, there's some specific angles that we know. And one of the angles that we know is we learned about vertical angles. And so when we have two lines that cross, and they're both lines, two lines that cross forms four angles. The angles across from each other are called vertical angles. So in this case, angle 1 and angle 3 are vertical angles. Now, what we can notice about vertical angles, and we did this yesterday, and that's abbreviation there, we know that vertical angles are congruent. So angle 1 is congruent to angle 3 because they are vertical angles. Okay, so then when we take a look at that, then we notice that, wait a minute, there's other ones that are also vertical, and that is 2 and 4. And so we learned that angle 2 is also congruent to angle 4, and the reasoning for this is vertical angles are congruent. Okay, and in a lot of mathematical statements, you say, well, it's obvious. No, you actually need to have a mathematical statement. So we know, and it's been stated, that vertical angles are congruent, and so that's what we're going to say there. Now, in addition to that, and so let me clear this out here. So in addition to that, we have some other angles here that we talked about yesterday. And those angles are the next door neighbors. Okay, so we talked about how the next door neighbor angles in this scenario, what are those called? Those are called adjacent angles. Adjacent angles are angles that share a vertex and a side. So when I look at angle 1 and angle 4, they share the vertex and they share a side. There's a side in between them. It's like an apartment that shares a wall. Okay, and so those are called adjacent angles. Okay, so I'm going to just say angle 1 and angle 4 are adjacent. Now, these, when I say that, that is not the only ones that are adjacent, because it's 1 and 4, 1 and 2, 2 and 3, 3 and 4. It's like all of them. In fact, I'll list them right here. Angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 1. And so these are all adjacent. So they're next to each other. They adjacent. I can spell. They're next to each other, and they share a side. I almost said wall. They share a wall. They share a side. Okay. So now, what's interesting about this is that they also, if you notice, the outside, the sides they don't share on these angles form a line. We call this a linear pair. So angle 1 and angle 4 are also called linear pairs because they form a straight angle. Okay, and so we can also name these guys a linear pair, and the linear pairs are supplementary. And so there's all sorts of things that we know about these angles. They're adjacent. Because in this scenario, the angles have all been formed by two intersecting lines, we know that they're called linear pairs, and we know, based on what we learned yesterday, that if I have two angles that form that line, they're supplementary. That means they add up to 180. So angle 1 plus angle 4 is going to be 180. Angle 2 plus angle 3 is going to be 180. Angle 3 plus angle 4 is going to be 180. Angle 4 plus, I think I already said that one, is going to be 180. Okay, so the ones that are next to each other are 180 in this scenario. Not all adjacent angles do this, but because it is formed by two lines, they are supplementary. Okay, and so that is how that works. Okay, and so those are the things that we knew ahead of time, and those are the things that are going to help us with where we're going today. So we've learned, okay, we've got parallel lines. You've known about that. We named the line that goes and cuts through those as a transversal. It could be any line. It could go left to right, right to left, straight up and down. It is a transversal. Okay. And then we've talked about those at those vertices, the angles that are formed. We reviewed what we learned yesterday. We have vertical angles. Vertical angles are congruent, and we have adjacent angles, and they are supplementary. They add to 180. So these things will help us for what we're doing today. So now we've talked about all of the angles surrounding one vertex. Well, what about the relationship of angles that are on opposite vertexes, on different vertexes? So we're going to look at this diagram here. So we have this line L. I think that's an L, but I'm not sure. I or something. Yeah, usually, anyway. Okay, and it is intersecting a pair of parallel lines. Okay, this line L is intersecting a pair of parallel lines, K and I. Okay, and so the parallel lines, I'm going to give you the little symbol and say that these are parallel. Okay, if these are not parallel, all of these things that we talk about today are not true. Okay, so in relation to the vertex, so we have two vertexes, two vertices. Okay, so I'm going to be talking about from that point. Now, we learned that if we had a triangle or a trapezoid or something like that, when we're talking about similarity, and this is really unrelated, I'm going to erase this when I'm done, and we look at the two figures. On the two figures, we have a shorter side on one and a shorter side on the other. Okay, we called those corresponding sides because they are in the same position, but on the, well, in this case, the bigger figure. Okay, so they're in the same position. We call that corresponding. So we're going to be talking then about corresponding in relation to this. So we have a vertice, and I'm just going to say, okay, so we have this top vertice. And to the upper left of that, in relation to the vertice and the transversal, which I will color red here just to give us, the upper left of that vertice, we have angle 1. Angle 1, okay, is in the upper left. So then we have this other, so then we have this other angle, and we're going to notice that in relation to this bottom vertice and the transversal, it is also on the upper left. We would call that corresponding. So in relation to the vertice, they are both on the upper left. One is in relation to the top vertice, one is relation and parallel line, and the other in the relation to the bottom vertice and parallel line. Okay? And so we call that corresponding. It is in the same position on the other parallel line, I guess. And so that is what corresponding angles are. So in this case, the corresponding angles, same position in relation to the parallel lines. 1 and 5 would be corresponding angles. Now the numbering can change. It's about position, not number. Okay, in this case, it's related 1 and 5. If we had a different numbering system or even used lettering, we would be saying like the position, upper left, upper left. Okay, so in this case, angle 1 and angle 5 are corresponding. Now, what we're going to notice is obvious. Okay, it's you can look at that and see, oh my gosh, angle 1 and angle 5 look like they're the same size. And based on that and knowing that the concepts from chapter 2 will prove that it is true. Corresponding angles are congruent. That's a relationship. Okay, so we're going to say they are congruent to each other. So in this case, angle 1 and angle 5. Well, then we could then look at other versions. So let's look at this guy, angle 2. So we're looking at the upper, in relation to the vertex and the transversal and the parallel line, the upper right. So we go down to this other vertex and we look at the upper right. These are corresponding. Now, another way that the book and other sources will use this is instead of using the colors, they will use different number of arcs. So the 1 arcs are equal to each other and the 2 arc are equal to each other. Okay, so in this case, I've got angle 2, and that is going to be congruent to angle 6. And you can see that. I mean, they look the same size. Okay, so then we just kind of go around here, and let's go with this color. Let me, oops. Okay, so these guys here, I'll use 3 little arcs. So that is in relation to the vertex, the parallel line and all that. It is the lower right. So these guys are corresponding. Okay, and so angle 3 is congruent to angle 7. Okay, and so that is that. And so I'm going to do a little highlighting here. All right, and then for the sake of just finishing this out, okay, so we'll look at the ones that are on the lower left, and that's really clear that they really do look like they're the same size, and so we're going to name those corresponding, and we'll do little 4 arcs. Okay, and we'll say that angle 4 is congruent to angle 8. And so, hold on. Oh, sorry.
I'll be back. I'm gonna leave for like an hour or so.
Oh, don't want to do that. Hold on. Okay. All right. So, corresponding angles are congruent, and you can see that. You can look at the colors, and they seem to match size-wise. Okay, and there's a set of acute angles, and there's a set of obtuse angles. You can kind of see that. 4 and 8, 2 and 6 seem to be the acute angles. 1 and 5, 3 and 7 appear to be the obtuse angles. And so you see that they match. And so corresponding angles are congruent. So that's the first relationship we have here. Corresponding angles are congruent. Okay, so if we know one angle, so I'll give you an example here. So if we know one angle, I can just kind of do this here. I'm going to do, oh, you know what? I'm going to change this up. It doesn't have to be that way. It can be this way. And so I'm going to go ahead and do this. Okay. So I know that, let's say that this is, this one's acute. So let's say it's 55. Okay. So based on the fact that it is it has a corresponding angle, there's a couple of things we know about this. Okay, so here's my 55. It is in the upper left. So if I go down to this one and say, okay, here we go, upper left, it's going to be this one. I know that's going to be 55. Now I'm going to blow your minds a little bit here because this is kind of cool. Okay, so if I know that's 55 and then I tack on to my prior knowledge, oh, look, these are vertical angles, so that's 55, and these are vertical angles, so that's 55. Just knowing that 155 gives me all of the rest of those acute angles. That's 4 different angles. I won't blow your mind anywhere past that, but that is the idea of what corresponding angles can do. It kind of makes those connections, like you could find other angles as well. Okay, so then this next one. So then what we're going to be looking at now is a different type of angle. Okay, and in fact, you're going to be able to see it from there. But okay, now this one requires you to have a general idea of some positioning. So the first thing I'm going to talk about here is the fact that there is an area of space between the parallel lines. And we call that area of space interior, which means that there's an area of space outside of those parallel lines. Okay, and it's top and bottom, and we call that exterior. And so when we're talking about, so we call that exterior. And so when we're talking about the description of angles and how they're related to each other. So up here we said that they were corresponding because they had corresponding positions. There are some descriptions that are going to be related to whether they're interior, between the parallel lines. So that's in this case with this numbering 3, 4, 5, and 6. Or exterior, outside of the parallel line. So in this case, that's angle 1, 2, 8, and 7, based on this numbering. Okay, and so that's the first thing. Okay, now another thing that you're going to notice, and I'm going to go ahead and throw this on here. Okay, so we also have, in this particular case, a left side of the transversal and a right side of the transversal. Okay, so in this case, when we're looking at 1, 2, 3, 4, 5, 6, 7, 8, so same thing. We have same side angles. So that's 2, 3, 6, and 7. Or we have 1, 4, 5, and 8. We'd call those same side angles. And then we have alternate angles. Now, why the same side? Because they're all on the left or they're all on the right. If they're all on the left, they're same side. So 1 and 8 are same side. 4 and 5 are same side. 2 and 3, 2 and 6, 3 and 7. You get the idea. 3 and 6. Okay. Alternate means opposite side. So that means if one's on the right, the other's on the left. If one's on the left, the other's on the right. Okay. So examples of that, but not excluding. So examples would be like 1 and 3. And I'm going to change that example. 1 and 3 that does work. But I'm going to say something like 1 and 7, or 3 and 5, or 4 and 6, because 1 is on the left and 1 is on the right. When you put those two concepts together, interior and alternate, it can give you some specific relationships. Same side, exterior. Same side, interior. And so that gives you kind of an idea. The one we're going to talk about right now is alternate. So not on the same side. One's on the left, one's on the right. And in these diagrams, they, depending on the diagram, it could be top and bottom. It just depends. So the alternate interior, so that gives you a big clue where they're at, angles. Interior, alternate, they're not on the same side of the transversal. Interior, they're between the parallel lines. So what that means is then, using that information, I'm going to go to that interior and I'm going to find some alternates. Here's one set of alternates. 4 and 6. 4 is on the left, 6 is on the right, and they're both in the interior. So we would say angle 4 and angle 6 are alternate interior angles. And so I will just say AI, alternate interior. Also, then we have angle 3. Oops, that is not what I meant to do. Angle 3 and angle 5. There, 3 is on the right, 5 is on the left. So we would say angle 3 and angle 5 are alternate interior. Now I want to go back to the diagram where we just labeled all of those things up there. So this one here, that one there. So we said once we knew 50. Okay. So what I want to do here is I want to highlight some alternate interior angles. So here's my interior right here. And so it focuses in on those. And my alternate. So I have one that is on the left, right here, and one that is on the right. And what do we notice about those values? They're both the same. They're both 55. When they're alternate interior, they are the same. They are congruent. So we can say then, relationship-wise, we can say alternate, but we're not going to say it that way. Alternate interior angles and I'm going to abbreviate that. So angles, using the symbol, are congruent. They're the same measure. Okay, so not only are they 4 and 6, AI, alternate interior, they are congruent. 4 is congruent to 6. Angle 3 is congruent to angle 5. And so there's another relationship. And so we can look at the diagram and say, well, yeah, because 3 and 5 are both obtuse and 4 and 6 are both acute. Okay, and so that is that is how we describe that, and that's how we can find some relationships. And if I'm given one number, I can figure out the rest. All right, so I'm going to jump here now. So now I'm going to use the same thing that I was just talking about. Come on. Okay, so I'm going to use that concept of we've got interior and then we've got exterior. I'm just going to highlight the interior this time. So here's my interior. And then we've got same side and we've got alternate. Okay, so on this one now, I'm going to talk about same side. So get a picture of that. So immediately I'm thinking 1, 4, 5, and 8, or 2, 3, 6, and 7. So same side, exterior. So those are the ones that aren't shaded. So the same side, exterior. So automatically angle 1 and angle 8, angle 2 and angle 7. Now what you're going to notice about these is that they're not the same. They're not the same. So angle 1 and angle 8, okay, those are not the same. One's obtuse, one's acute. So we need to do a little more development into this. Okay, so I want to remind you then, okay, that when we're looking at this, well, let's just take a look at that. Let's put a number in here. Let's see what happens. Let's see what that relationship is. So let's put a number in here. Let's say that 2 is 50. Do something easy. Okay, 50. 1 and 2 form a straight angle. We talked about that back when we were just talking about vertical angles. So they're forming a linear pair. They're supplementary. That means that angle 1 plus angle 2 is going to be 180. So if I know that angle 2 is 50, what is that? Because I'm going to subtract that. So 180 minus 50, that's got to be 130. So I know that this is going to have to be 130. Okay. Well, now let's play some leapfrog. I call this leapfrog. It's like, oh, look. So if this is 50, then 4 is 50. Vertical angles. Well, 2 and 4 are vertical angles, so they're equal. Oh, look, 4 and 6, alternate interior angles. Oh, that's 50. Oh, look at this. 6 and 8 are vertical angles. That's going to be 50. Okay. Well, let's make the other leapfrog. So I'm going to get rid of some things here because it gets really cluttered when you start putting everything in. So I'm going to, then we'll come back to that. We said that's 130 because they're neighbors, they're adjacent, and they form a straight angle. So they have to add up to 180. Okay, so let's look at these. Oh, look at 1 and 3 are the same. They're vertical angles, so that's going to be 130. Oh, look at 3 and 5. They're alternate interior. Alternate interior are congruent. They're equal. 130. Oh, 5 and 7. Look at them. They are vertical, so that's going to be 130. Look at all these things that we've got. Okay, now I'm going to come back and we're going to re-highlight that because when I'm talking about same side exterior, I look at that 1 and 8, and we knew because 1 was obtuse and 8 was acute that they can't be congruent. You really have to think about that. Okay, that means that 1 and 8 are supplementary. Okay, and so same side exterior, so same side exterior angles are supplementary. So same side exterior angles are supplementary. They add up to 180. And so you can see supplement. I talk and I write at the same time, lose track on these long words. Okay, so we talk. That's why I went over vertical, supplementary, and complementary yesterday because of the necessary prior knowledge to understand all of this. And so you can look and you can see other pairs of supplementary angles. And so I'm going to do one more because this is kind of a combo of 2 sets of notes. Okay, I'm going to do one more. Okay, and it is that same side idea. Okay, so we're going to do again. I'm going to come back here. I'm going to highlight this in the middle. So here's our interior. You can see where the exterior is. I'm not shading it. You know the concept of same side. So I'm going to tell you right now, they're going to be same side. So automatically, you're looking at 1, 4, 5, and 8, or 2, 3, 6, and 7. Same side. But this time we're going to look at interior. Same side, interior. Oh, well, let's go back up to this diagram. What happened to those same side interiors? 4 and 5. So That was 50 and 130. So we see then that same side interior angles. And in fact, we don't even use an arc for that. So same side, and I'll just circle them. Interior angles. They get an acute and an obtuse. So immediately you should be thinking same side interior angles are supplementary. All right. And I'm going to just do one more because we can. Okay. What if I said alternate exterior angles? Alternate exterior. Okay, exterior 1, 2, 8, and 7. As soon as I see exterior, I'm like, okay, 1, 2, 8, and 7. So let's just pick two, and then look at alternate. So here's 2 alternates. 2's on the right. 8 is going to be the alternate. So that's angle 2 and angle 8. And guess what? Are they both the acute angles, or are they one of each? They're both acute. So not only can we say that angle 2 and angle 8 are alternate exteriors, they are congruent. So angle 1 and angle 7 are alternate exterior. Angle 1 is congruent to angle 7. Okay, same side interior. I didn't list those. That's angle 4 and angle 5, angle 3 and angle 6, so that we can list these for the examples. Okay, so that is the way that works, and there's relationships that are super important, and we can figure these out based on all of these relationships, based on having one piece of information. We can fill in all of the rest. Okay, just one more example of that. Let's just say that this is use orange. Let's say that this is 110. Okay, automatically, if this is 110 and I'm looking at this, then I am knowing that that this is 70, because 110 plus 70 is 180, and it has to be 180. Okay, so that means that this is 70, that this is 70, and that this is 70. It's like kind of back and forth, that alternate idea. This is 110, 1 is 110, so 3 is 110, 5 is 110, 7 is 110. Done. I have all of the angles. That's awesome. Okay, once you understand the relationships, it's pretty easy to figure out. It's just learning the relationships that makes it kind of hard. So that's all I've got to say. I have added more concepts: the same side exterior, same side interior, and the same side and the alternate exterior. Those are all added from yesterday. Okay, so good luck with this.